Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to use the remainder theorem to evaluate functions, polynomial functions. So if we divide a function f of x by x minus k, and we learned how to do that with synthetic division in the last video, the result can be rewritten in this form. The function is equal to that divisor multiplied by the quotient that we found plus the remainder. This allows us to evaluate a function for a value k. Let me change colors here real quickly. If I'm trying to find f of k, I put in k for x. So that's going to be k minus k times the quotient evaluated at k plus the remainder. But k minus k is 0, and that makes this whole product 0, leaving only the remainder. So if we do division, synthetic division, and we get a remainder r, that is also the function evaluated at k is equal to that number. And so we're going to use that. We'll do a little more synthetic division, a little more practice is good, and we'll use that to evaluate the function as well. Now, if I had to evaluate this function that I'm given for 5, I've got to multiply -3 times 5 to the 4th, and 15 times 5 cubed, and 50 times 5, and then I've got to do, the arithmetic might get a little out of control there. And so if I'm using a calculator, it's not a big deal. But if I'm trying to do this without a calculator, synthetic division might actually be a little easier. Let's see how this goes. We're in that divisor box. We're going to put it in 5. The leading coefficient of the 4th degree term, that's a -3. The 3rd degree term is positive 15. There's no x squared term, so I'm going to put in a 0 as a placeholder. Then I've got -50 for x and 17 for the constant term. Bring down the -3. 5 times -3 is -15. 15 minus 15, that's 0. That's good news. 5 times 0 is 0. Write that on the next line. 0 plus 0 is 0. More good news. 5 times 0 is 0. -50 plus 0 is -50. And so 5 times -50 is -250. And probably the hardest arithmetic that I've had to do in this problem is 17 minus 250. That's -233. That is f of 5. That was actually pretty straightforward, right? Let me show you how this would work if I were to actually plug this in. F of 5 is -3 times 5 to the 4th power plus 15 times 5 to the 3rd power minus 50 times 5 plus 17. 5 to the 4th power is 625. So -3 times 625. 5 to the 3rd is 125. So I've got 15 times 125. Minus 50 times 5 is 250 plus 17. -3 times 625 is -1,875. 15 times 125 is 1,875 minus 250 plus 17. Those two terms add to 0, leaving me with -250 plus 17, which I just figured out up here. So I do get -233, but the work seemed a little friendlier in the first one. So there's a plus to that. If you've already done the division, it's a faster way to evaluate a function than plugging it back in. All right, I've got two more for us to do. The first one says, let f of x equal x cubed minus 7x minus 10. Use the remainder theorem to find x minus 8. I'm sorry, to find f of negative 8. So I'm going to put negative 8 in the divisor box. We're starting with x cubed. I have 1x cubed, 0x squared, negative 7x, and negative 10. Whatever your degree of the polynomial is, here it's 3. You have to have one more spot than that in the top line. So there are 4 spots, but I only see 3 numbers. That means that I'm going to have a 0 somewhere, and I've got to figure out what spot that is. Right. Bring down the 1. Negative 8 times 1 is negative 8. 0 plus negative 8 is negative 8. Negative 8 times negative 8 is positive 64. Total that column. Negative 7 plus 64 is 57. Negative 8 times 57 is negative 456. We add those two together. Negative 10 plus negative 456 is negative 466. And that is what f of negative 8 is equal to. Now again, you could work this out, but that is the right result. This last one, we're going to evaluate a function with a complex, for a complex value, 3 plus 4i. This one's going to become a little trickier. Let's see what we get. I'm going to put 3 plus 4i in the box. My biggest degree is x squared, so I need to have 3 spots. The degree of 2, I need 1 more than that for the number of spots. 3 spots, I have 3 coefficients, so I can write them down in descending order. 2, 6, negative 21. Bring down the 2. 2 times 3 plus 4i is what's going to go here. So when I distribute the 2, I get 6 plus 8i. Let me undo that. Now we're going to add those together. 6 plus 6 is 12. So I've got 12 plus 8i. Now in this last spot, I've got to multiply 3 plus 4i times 12 plus 8i. I'm going to do that off to the side. 3 plus 4i, 12 plus 8i. This is that FOIL style multiplication. 3 times 12 is 36. 3 times 8i is plus 24i. 4i times 12 is plus 48i. And then 4i times 8i is 32i squared. 32i squared is 32 times negative 1. And there are a couple of like terms I can combine. 36 plus 72i minus 32. Combine a couple more like terms, and I get 4 plus 72i. So that's going to go here. And now I need to add these together. The real parts first. Negative 21 plus 4 is negative 17. And then I just bring along the plus 72i. That's the remainder. And that tells us that if we were to substitute 3 plus 4i for x, we would get negative 17 plus 72i out for the function. All right, that is it for the remainder theorem. In the next video, we'll actually use the remainder theorem. We'll use synthetic division to try and find some roots of a function.